Okay, so let's begin. My intent today is to give you guys cultural background on Android development, okay? Um, for most of you, but for some of you, for the top performers, these will actually be requirements to you for you to guys to achieve top grades, okay? You will understand it in a while. Regarding the overall students, these subjects are to be addressed on the exam, but only from a perspective of culture, okay, understanding of the overall um, Android development area. But you will understand in a minute what I'm trying to say now, okay? But for those of you who wish to have top grades, you will have to deal with this, okay? But I will not show you how. I will only talk about it, okay? So my goal is to see how you will face these issues, okay? So the subject today is about background work. Um, thus far, okay, maybe I started too soon. No, no, not really. Okay, so far we have been concerned about user-facing applications. I'm going to close the door. Uh, about user-facing applications, okay? Meaning that we are aiming at applications that the user is using them, okay? Looking at something that the application presents on the screen, okay? For example, I'm talking about this. Let me just start our demo project. In our case, you guys are building a game, right? Which we presume the game is to be played, right? So we are using something that is being displayed on the screen. But the point is, what happens when, let me just start the application. What can happen if, okay, let's run it. I was waiting for it to stabilize. What do I actually mean by background work? Okay. In a moment, this will start. Okay, so we have here an application. It doesn't matter what application it is. It's our demo application. But when we are looking at something displayed by the application, this application is called foreground application because it is using something on the screen, right? It's displayed. Once we do this, home, what happens? You see what happened here? The application is no longer being displayed. It is no longer using the screen. The question is, what happens to computation? You understand the question? What happens? Is it our application still running or not? You understand my question? We have this. Is our application running or not? Is it using computational resources or not? What is your expectation? What do you guys think? Is it or isn't? The application is this. And more, why do we care, right? We may not care. I don't care if it's running or not. Who cares? But we do care, right? Why? Well, because when we are playing a game, in particular your game, we care if our application has been destroyed or not, right? Is it running or not? Is it using system resources or not? We actually care because we are inside a game. We are playing the game, right? So the question again is, okay, cool. I did this. The application is running or not. What is your expectation? What do you guys think? Hmm? Yes? More answers. It is running. Is all of you agree? Yes, it is running. Is that your expectation? It is using system resources? Is it? Hmm? What, what does that mean, not as intensively? What do you mean by that? What is intensive use of computational resources? And what, yeah, okay, it's not on in the foreground. Yes, we can see that. But what does that mean in terms of using of resources usage? Why do you thought of intensive use versus non-intensive use? What do you mean by that? In what it translates to what actually? You understand my question? Okay. So your expectation is that it's using minimal resources, uh, 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 but that is relative to, wow, this stopped. It shut down and restarted. Okay. I was not expecting it. Okay. It was not intended. But again, let me just run this. Um, so, but in respect to what? Because it's not using the screen. Is that it? Mm. But in how does it translate to us, so application developers? Do we see it in somehow, in some way? Do we perceive it, or are you answering regarding expectations that the system does? Is that visible in our development developer's mind? Do we need to be concerned about that or not? Or are we just talking about expectations regarding what the system does, and that does not translate directly into our worldview as application developers, Android worldview, meaning you never thought of it. You just think it's okay. It's a matter of system concern, and I'm trying to sum the conversation. So, if I understood correctly, you guys are telling me that okay, um, regarding the system, we have actually expectations that translates to not using that much computational resources. But look, memory, the garbage computational resources are twofold, at least memory and CPU. We are not using CPU at all. Were we using CPU here or not? What do you guys think? Is the CPU being used by us? Yes, no? I'm concerned with directly, okay? Because indirectly, most of the times we only have we don't have expectations. We don't have certainty. Okay, I'm here. Are we using CPU or not? Look, it's a menu. I've displayed it. The CPU is not being used. That's for sure. We need to be capable of answering this. Okay, so no, we are not using CPU because we are not processing anything at all, right? The CPU was used once when this had to be displayed on the screen. But now it is on the screen, right? At most, it's using graphics card memory, at most, right? I'm not using anything else here because I said display this on the screen, and that's it. And it's over. I'm not touching anything. So from the point of view of CPU usage, we are not using explicitly anything, right? because I only had to say, look, display this, please, and it's there. And from the point of view of memory usage, well, we are on the foreground, meaning that the process has something that is being displayed. Therefore, the process, the host of the application, is using resources, memory, and the memory which has been requested by the process, it's there. It's being used unless it's garbage, and we no longer have references for those objects. And if we don't have references, the memory has been garbage collected. But regardless of being or not garbage collected, all memory which is globally reachable, right, it's committed to the process usage. Therefore, we are using resources, those that are required to reach, to have all duplication state or duplication data. Okay? So yeah, we are using resources, and there's no expectation that those resources are usage is less than usual. Why is that? Because it's application data. It's reachable. It's there. It doesn't go anywhere. But my point, or our concern, is what can happen if we do this. Once the application ceases to be a foreground application, it's on the background, the system actually can determine that it's time to kill it. Okay? Remember when I told you guys that on activity, the on destroy callback for the activity was not certain to be called? I told you guys, look, on destroy may not be called. Okay, this is the use case where it may not be called. What happened once I did this? Once I did this, which is the state of this activity? What is the state of this activity? Hi, good. What is the state of this activity? You understand my question? Not really? Do you understand the question? The state of the activity? Remember this? Remember this? What is the state of the activity? Here. Resumed? In this screen, in this diagram, where is it? Blue, orange, or green? Green? Okay, so the activity is visible. It's being displayed, therefore it is using the screen, therefore it is in the running state. This doesn't mean that it's actually executing code. No, it means that it's in the visible state. It's visible to the user. What happens once we do this? Home. Where is it? Where is it? What would you think? But it's no longer visible. Something must have changed, right? The activity is no longer visible. Yeah. If we look at it we see another activity comes into the foreground. In that case, it wasn't another activity that came into the foreground. I simply sent the user task to the background. This means that the activity is no longer visible. It is stopped. Right? So the activity is no longer visible. So, but why do we care? Again, the question is always, okay, there's a lot to know in this universe. Why do we care about this? What does this matter? Yeah, it is, Sander, it is. Oh, Alexander, how are you? Okay, so guys, come on, don't be afraid to make mistakes. It's okay. We are learning, we are always making mistakes. Risk it, come on. Em português, be tight. Não diz be tight. Se stress. There's nothing wrong about being wrong, okay? Risk it. Yeah, come on, just to have a conversation. Go ahead, man. Let's do this. Risk it. What do you think? Because what is my goal? Why am I asking these questions? Because I'm trying to figure out how your mental model is organized, so I can tune my discourse to help you guys to understand. Because for me, this is obvious, right? But as someone was saying, actually, this is one of the most complex parts of Android, okay? So it's not common for us to be concerned about this. This is why I left this for the end of the semester. And this is why I will ask you guys about this stuff on the exam, okay? I will. But from the point of view of how demanding I will be, it will all I will be demanding for those that are aiming at top scores, okay? Not for everybody. But regardless, we have to understand that something happens here, okay? This is why I'm talking about this. So remember, again, we don't have to know all of this by heart, okay? If we look, I know it by heart because it makes sense to me, okay? And this is what I am aiming. I want it to make sense to you guys. There are two states that are relevant in the activity. The most significant ones are the activity is not visible and the activity is visible. Those major states are very important because they determine a lot. If the activity is visible, it owns the screen. The screen, it's hers. It's from the activity. This means that it's the most important thing in the system. It's weird, right? But it's true. In the system, the most important stuff in an Android system, the most important stuff is the thing that the user is looking at. Okay? If the user is looking at it, it is hugely important. It's the most important thing because if everything is about user experience in a mobile device. Okay? So this is the most important piece. Let me just close this to eventually free resources. And now we can go back to this. Once I do this, I choose it again, okay? It becomes again the most important thing in the system because the user is looking at it. What if I do this? Is it still the most important thing in the system? For sure it isn't because the user isn't looking at it. What is the most important thing in the system now? Well, it's the home screen because the user is looking at it, okay? So this is something I want to convey to you guys, to make you understand that this is the nature of a mobile device, and this has determined a lot in the design of these systems, okay? This is not simply a variation of a unique system. No, it has important changes regarding user experience, like this one I just said. When I do this, is it the application running? What is your expectation? Is is the application running or not, right? Apparently, we click here and we see there something, the user task. Remember the user task? It's there, right? This means that the application is running. Is the application using resources? And the answer is we do not know. We cannot know for sure. Okay? Why is that we cannot know for sure? Because the system may determine to kill the application, simply because it's no longer important. Okay? This means that for any reason, if a given application is not important, then the system may choose to kill it. And this means that the on-destroy method will not be called. The application will be headshotted, right? It's a headshot. It will be forcibly terminated, just like that. Why? Because the system can. The system is saying this is a part of the programming model. The system can, at any time, if a given application is not important, may kill it at its own discretion. Okay, and this has huge consequences in our mental model. Why is that? Because imagine this: we are here and we are fooling around with the jokes demo. Then I go to the background, like this. How many applications are there? One or two? Come on, barra parede. How many applications there are? One application, but two user tasks. These are not instances of the application. There's only a single process, but there are two user tasks. Remember the user task and the backstack? There are two here. I'm using two of them, but we can have more user task demo. Okay? There are three now. Three user tasks, a single application, a single process. For me, the application is the process in this course, okay? Okay, guys? If we do this, is our application, our single application, running or not? And the answer is we cannot know for sure. We do not know. Meaning that, but some of you guys tell me, but we can kill the application like this. If I managed. Go away. I cannot do the click and swipe. Yeah. Oh, come on, really? So I'm very fast. Is that what you're saying to me? You won't have any extra credits, okay, for that. I'm joking, okay. Let me just, okay, cool. Okay, I hate emulators. I would love to show you guys this, but what this does, the swipe up, what it does is to kill that user task. The application is still there. It's the user task that went away. Oh, by the way, when we do this, there are three user tasks. Is the application running? Is it? And the answer is we do not know. What we know is that there are three user tasks. This means that it's possible that if the application is forcibly terminated, that once we again go to the corresponding user task, that user task is restored by the system. Okay, it will be restored automatically. Okay, but to what extent? Well, for example, if we are in the joke of the day, for example, one thing that may change in this demo is that reverts to the idle state. So the user will see, unless we do something about it, the user will see that something has changed. If we don't store state persistently regarding the user credentials, the authentication token, you will go back to logged out state, to not authenticated state, because we haven't stored those credentials persistently, right? The authentication token. It was in memory. The process was destroyed. Everything that was not saved persistently, it's lost. It must be recreated. Okay? So this is an important thing. Okay, Sander, maybe outside, right? But it doesn't. I think you guys understood my point here. Okay. So the question is, remember, we do not own the lifetime of our application, and this is so extreme, so that it can happen that I am like this, and the application is terminated for me. Okay, I have no control about that. This is distinct, different from what we are used to, right? Because the application stays there until all its threads, all its non-daemon threads, and remember, I'm thinking of desktop applications in particularly, right? This is not true here in Android, okay? Simply not true, because the application may be forcibly terminated. This is why the on-destroy method is not, we have no guarantees whether it is always executed or not. In this case, it will not be executed, meaning, okay, we must be attentive of that. Let me just see whether, stop this. It's not an easy thing to show, right? Because I do not control the system, okay? I have no way of telling the system, okay, kill this, or kill non-important applications. Okay, actually there are some ways to go about it using package manager and activity manager via ADB, but I think that's over the top. Well, there's no point in doing that. Okay, so I will share with you guys these links. Everything I'm saying here to you guys here is written here. An application, or let's look at the process. We now are the system, okay? We have a system perspective point of view. The system sees processes and it determines their relative importance. The system is under stress. It needs to reclaim resources. So it looks up to the process it has and looks, okay, which are the important processes and which are not. And let me just kill those that are not important because I am in crisis management. I need to kill processes, okay? And it looks up to those processes and see, okay, this one is not important and this is important. I will shoot down the non-important one, okay? And for now, I told you there's one criteria about process importance, which is, does it host a visible activity or not? If it doesn't host a visible activity, it is not important, okay? It's not a foreground process. One means the most important type of process is a foreground process. A foreground process is one that has a running activity. By running, they are meaning visible, okay? According to this diagram here. It's an unfortunate name, in my opinion, because it's not running anything at all. There's no code running there if the activity is idle, just displaying something. I don't like the name running, but yeah, it's not for me to choose the name, okay? So it's visible. Okay, thank you, Ironic. So I was saying, remember, once the activity, let me just do like this. Once the activity is no longer visible, the foreground annotation is no longer earned by that process, meaning that the process is no longer foreground, okay? There are several layers of importance here, which ones are those? For me, at the moment, I'm merely concerned with two of them. Either there's something visible in the screen, or it has nothing visible on the screen, and that makes a huge difference between being important enough or not important enough. Okay, but there are several here. Okay, so you asked me. Yeah, we can. Yeah, we can do this, Sonder, by using package manager or Android activity manager. I know. Yeah, yeah, I know. Yeah, even easier this one. Let me just look. ADB, okay. Then ADB force quit and kill. Let me just see. Okay, let me try to get what you are saying. You are saying what? Run this. I don't know about that. How are you saying now? Look at Locket. Cool. Yeah. Trying to learn something here, guys. Let me just and right click your my process. Where? Here? Ah, very nice. Cool. Like so. Let's go. Kill process. For stop application or kill process. Thank you, Sander. Cool, cool, cool. This okay. I've just killed my process. Look, it's still there, right? Apparently. I just killed the process. Thank you, Sander. Very nice tip. Thank you. I just killed the process, but it's there or not. It's the user task, which is stored persistently by the system. Let me click it. It creates a new process once I elect to use that user task. Yeah, the process is recreated, the user task is restored, and everything is created anew. In this case, because we do not have any state, what do we see? Nothing special. All is well, apparently. But what happens? I will use this. Well, I didn't know, Sander. I didn't know. It's cool. It's very cool. Now, importance is about being seen in this case. It's foreground because it's something there being displayed. In this case, it's not being displayed, right? And yet, the user task is still there. The user task is a system construct that stores information regarding the user experience while using that application. But the process may not exist because this is stored by, this is an image, okay? It's a snapshot of the screen when this user task was last displayed, okay? So this means that we can actually think we have the application there, but it's not there, really. It has been destroyed, the process has been killed. Why? Because it was not important according to this criteria. Okay? Right? I answered your question? Yeah? It's not, but the question is, what about the view model? It has state, what happened? It was lost unless we did something about that. Okay? But it was lost. How do we know that something is about to happen? Well, we have two callbacks, on save instance state and on restore instance state. Those callbacks of the activity lifecycle are the callbacks that are used by the save instance state. Okay, remember save instance state? Remember savable. Remember that hook, that function from compose, it stores information using that mechanism, the mechanism from on save instance state, on restore instance state. By the way, remember this. let's look at this here. So you were asking me in the last lecture, how ready are you guys to enroll a professional team, right? How ready are you? Well, you are ready to be productive from day one. You don't know everything, so you are not ready to alone build a product. That was never my goal here, okay? But you are ready to be productive from day one. But you will need help, okay, or time to understand something more stuff about the programming model. This is what I am trying to do in these two last lectures, trying to give you guys some insights about what is left, what you need still to learn, okay, if you guys go on a solo venture of building a product with an Android application on it, okay? So, tell Guga, tell. Yeah, state recreation test. Sonder is saying, look, we need to test this, so we need to have a state recreation tests. Those state recreation tests mostly are manual. For sure, you are doing that manually, right, Sonder? But regardless of being manual or automatic, we need to execute them. We have a script. Those are the tests we are going to do. Those that we can do automatically, we will do automatically. The other ones, we will do manually. Okay, but we will need to do them. Okay, yeah, okay, manually for sure. So I was saying, remember this, that on save instance state. You see here? Okay. Oh, by the way, you may see this and this. The difference is that this is stored in such a way that it will survive shutdowns. Okay, device shutdown. This only survives application shutdown. It does not survive device shutdowns. Okay, the difference is that this state is stored out of process in a system process dedicated to that purpose. This is stored in the file system. Okay, if we actually want our state to survive even device restarts, we use this and not this. We can choose something to go here, something else to go here, but this is the hook point where it all starts. Let me save state so it can be restored if the process is killed while the user is not looking, to the device is shut down and restarted. What does this mean? Okay, so this is the one of them. We have two. If I don't care about that one, okay, we have two overloads. Okay, one that receives only the bundle, and one that receives the bundle and the persistable bundle, the one that is actually stored on the file system. Okay, guys, this is the on-save instance state. We have the save state. We have the other one, on restore. Override on restore instance state. Here you have it. Usually, we don't need this one. There are some use cases where this makes sense, but usually we use the on create. Okay, the on create instead of this, because on create also receives either one. Make sure you guys know, well, try to make sure you guys know, is overall culture regarding this. The actual use will only be required for those which are aiming at top grades. Okay, I'm talking 17, 18, 19, and 20. Top grades must in some way have concerns regarding this. Okay, if you are not concerned about this and don't do anything about this, you will have a hard time achieving top grades. Okay, why is that? Because this brings complexity to the table, and I want to see how you guys fare with that complexity without me guiding you through it. Okay, this is what I mean by top performance. 18 or plus must show me what they are capable of. Okay, without me showing you guys how to do it. Okay, fair enough, you think? No, not really? You are still numb. I don't know what to say yet. But yeah, that's the general idea. Okay, guys? So again, uh, the point here is this. Okay, cool. I am playing the game, right? State is mostly a nuisance or a quality of life. It's obviously, sorry, it's my kid. Let me, she's abroad. She lost her wallet. Let me see, check if is everything okay or not. Okay, all is well. She was just not mindful that I was in the class. Okay, cool. Let's continue. So again, um, what was I? Okay, I was talking to you guys about what happens when the process is killed. If I haven't done anything about it, some part of the state will be lost. Okay, this can be a nuisance or not. It depends on the application itself. While in the game, we are playing a game. What happens? We are playing the game of poker dice, right? What happens? The process is killed. Well, we forfeit the game, right? We received a call, an urgent call or not, like I just did right just now. And what happens, right? Well, the process may be killed. Why is that? Because the user task is no longer facing the user. So the process is no longer the most important thing happening in the system. The most important thing, like a father, is I just received a call from my daughter. So everything else is secondary, right? The same as in Android, in its design. This is above all other things, it's a phone. Okay, it's to be used to call people. Okay, so the game is secondary, but it's a challenge. How do we keep playing the game? What, how do we make sure that the process is not killed? Well, we keep that process, we assign it an importance. We must give it importance, okay? How can we give importance to a process? Okay, how can we? And how do we make sure that we execute work on the background? I'm just saying, look, if the process doesn't have anything being displayed, it's not important. If it's not important, it does not execute, or we do not have a warranty of it being executed. So how do I do background work? There are several ways to do background work. And it's not by launching a background thread, okay? Because the thread by itself does not give importance to the work. I need to use something else. And one thing is the Work Manager API. Manager API. Okay? This API allows me to schedule tasks in such a way that the system understands that those tasks are important. Okay? It's the Work Manager API. I can schedule tasks and I can specify what are my execution requirements. For example, I can say, look, I want this to be executed every 8 hours, give it or take, okay? Or I want it to execute every day. Or I want to execute it every hour as long as I actually have network, because I'm going to perform network requests. Okay, so this is an API that is used to schedule work. It's not our use case. In the game, we are not going to use this. Okay, this is used for scheduling work, as I just said. For example, no, for alarms, we have something different. Alarm in the sense of waking me up. No, that is the alarm manager. Okay, it's something entirely different. This one is to schedule work that can be periodic or not, or one-time request. And while doing it, even if there's nothing left visible in the screen from my application, while doing it, the system understands that that process is important enough to keep alive because something is happening in the background. And you would say, whoa, this is great because this is a way to bypass those requirements of the system. No, you have 15 minutes to do it. If your work takes longer than 15 minutes, it will be forcibly stopped. I think it's 15 minutes. The last time I checked it, it was 15. The point I'm making here is no, it will not be forever. Okay, you have a time frame to execute the work. Okay, but not for alarms. It has periodicity specification. I can specify how frequently I want to repeat this work. Whether, for example, look, I want to execute this only if the device is cradled. Cradled is connected to, okay, to a power source. It's what it means to be cradled. At night, for example, I have something in my nightstand. I put the phone there, so it wakes me in the next morning, and while doing it, it's being charged. Okay, this is being cradled. Okay, so I was saying, cradled. I can specify if, for example, I need network to make some requests, and the system will only execute my work if all the requirements are met at its own discretion. Okay, trying to respect my wishes, of course. Okay, but while doing it, the system has information that this is important enough. It's not our use case for the game to make sure that the game keeps on being played while I'm answering the phone. This is not it. It's not with this that we will solve it. How will we solve our use case? Using a foreground service. What is a foreground service? Is here. Okay. So this is this is not here. The set of links. Importance given to processes. It's here. Okay. Then how will I go about using executing background tasks? Okay. And what kinds of background tasks and the system restrictions of those background tasks. Okay. This is a decision flow. How will I use this? It's more or less what I'm trying to explain to you guys. Pardon me. Here. And finally, we will look into this later. And finally, so in this case, we will need a foreground service. So now I need to talk to you guys about the several types of components in Android, okay? Okay, there are 4 kinds of components in Android. Remember what's an Android component? Those elements that are potentially entry points of the application. What does this mean, really? It means that execution starts not at function main, as in a JVM application, right? No, it starts on a callback from an Android component. And on the activity, it starts where? On the launcher activity on its own create. Remember? On create method. Remember? So, activities. It's the component we have been using so far because we have been dealing with user-facing applications, those that have something to show to the user. But these are not the single components in Android. There are others. And another one is a service. The purpose of a service is to execute work that is not user-facing, meaning that it doesn't have to have a user interface. This has been abused in the past. Okay, so earlier, oh, Pablito, thank you. Earlier, I was saying, earlier, maybe we are at 2025, maybe 2010, 2011, maybe, yeah. Applications, Android applications were comprised of activities, services, broadcast receivers, and content providers. The whole shebang, right? Everything. All of those broadcast receivers, by the way, let me just write them here. Receiver, content provider. We used every single component, Android component. This has led to a multitude of issues, and therefore the restrictions were imposed in these two, the use of these two. Okay, so what is a broadcast receiver? Is a system level event listener. Okay, we create a broadcast receiver which has a single callback on message. Okay, which handles the event represented by that message, okay, which is issued either by applications or by system itself. Currently, most applications do not issue broadcast intents. Okay, why is that? Because there have been severe restrictions on them. Okay, due to security concerns. Okay, I will not elaborate on that, but that's the general idea, and the same as applied to the services. Why is that? Because the concern is about battery management. Okay, so we want to build applications. The system wants to preserve battery life. Why is that? Because that's an important selling point. Okay, if I have a device which is all powerful but only lasts for 1 hour or two, I will not use it, right? We want systems to have long life, right? To run at least for a full day, okay? And that is not only about battery technology, it's also about system software technology, and that has consequences on our programming model, okay? So I was saying, this is about a component that has a visual manifestation. It uses the screen. It is user-facing. This is about work, which is not user-facing. This is about listening to global events. Okay. Network. Battery is low, below a given threshold. It is issued through a broadcast receiver. Everyone knows about it because batteries becoming low. Previously, we have also one that I no longer have network, or I do actually have network. We are connected. We are no longer connected. This, given the nature, the intermittent nature of connectivity, was a major issue regarding battery preservation. Okay, so it has been discontinued. We no longer have that, at least not with the accuracy we would like. So we don't have that, not by these means. And finally, the content provider. The content provider is a component that provides access to data. For example, we actually have a content provider to access information regarding contacts, the device's contacts. We can use it through a content provider provided by the contacts application. Okay, it's a content provider component that is provided. I am saying all of this. Why is that? Well, because you will look, and while reading the documentation, you will find these words. Okay, and you need to understand at least what they are. It's this. Regarding our use case, I was saying to you guys, well, we will address it using a foreground service. A foreground service is a special kind of service that, although the service has not been designed to be non-user facing, a foreground service must have something displayed on the screen. Usually an icon in the notification bar. Okay, this that is a foreground service. What is the goal of it? Well, it's to make sure that if anything is happening in the background, the user is aware of it. And he knows that it's being used. For sure, you guys already noticed that sometimes you have on the topmost bar something there. The application left it there, right? So we can select it and press again to go to our application. This happens in many applications, okay? So if you guys actually want to make sure that you keep on playing, you need a foreground service to keep the game active and displaying something in the notification bar. The notification bar is accessed through the notification manager. Okay? Again, I will not show you guys how, because this is for the top performers. Okay? So, but remember this, the notification manager is the API by which we can use the notification bar. A foreground service is a service that also has something displayed on the notification bar. Okay? It's simple enough. It's not very complicated. So what brings the complexity that I'm talking about, it's not about the thing itself, but on the consequences on the overall application. Okay? The thing itself is simple enough. I could do a demo. It's not complicated. Okay? But the consequences on our application architecture are more irrelevant. Okay? So I will leave to you guys to do this, if you wish to, of course. Again, okay, cool. So let me see whether this is the conversation here. If that, why doesn't the system destroy the process in these cases? Well, simply because it has a foreground service. Okay, the process has a foreground service, a visible process. Something is visible there, not actually using the whole screen, but on the notification bar there's something there that we can look at it. Okay, so that is what's giving the process itself the important trait it's required to ensure that the system does not kill it next. Okay. Oh, by the way, it's some of you may think, look, I'm playing. I receive this phone call. It's just a brief moment. I go away and I listen and I talk to my daughter, right? What are the odds of the application being destroyed in the meantime? Really? Is it a problem? What are the odds? Let us imagine that we have a 0.01% probability of that happening. 1 per 10,000. Okay? If you guys deploy your application in a million-fold, million strength user base, I can assure you guys that it will happen, and you will receive bad reviews for it. Okay? Keep that in mind. When we are at scale, and that is our goal, right? We want to reach as many people as we can. When we are at scale, things will happen frequently. Okay? That is my own experience with this. Because we have a million strength, actually more than dozens of users, it will happen for sure, and it will give us bad reviews. And what happens? You know what happens when we get bad reviews? Top brass becomes nervous. Top level managers, they become nervous because that's visible to the world, right? It's about the image of the company, which is a thing that is expensive to maintain. You all know what is the street reputation of Ubisoft? Why is that? You know how hard it is to get rid of that reputation, right? So it's a big deal. Okay, it's a big deal. So, guys, so I will give you these links. You will look into them to become informed. Those of you who wish to give it a go at trying to address this, it will be my pleasure to answer your questions, okay? As long as you don't ask me, how am I going to solve this? I will answer, I don't know. You ask me better questions and I will help you, okay? I will not give you the solution, but I will be glad to help you guys trying to address this. I will give you pointers, okay? So, but give it or take, it's this. For our use case, it's a foreground service, okay, with something in a notification manager. That service is only launched when the application goes to the background. And I know when the application goes to the background. How is that? Well, I have an on-stop on the activity, right? The activity transitions to the not visible state, and the transition to not visible state leads to calls to on-stop. Okay, cool. Again, another thing, and I will end right after this. Okay. So I talked to you guys about Work Manager. It's about scheduling work and specifying its requirements. It's easy enough. It's an example. This here, look, get instance of the Work Manager, one-time work request, create one-time request using the full worker, which specifies the work itself, and let's enqueue that. Okay, it's simple enough, which means this is something I wish to be done. Take that. Okay, this is an example. This is another example. Enqueue request, one-time work request. Let me show you a periodic one, a periodic work request. Periodic. I will give you a better link than this, okay? This is a poor link, Work Manager. API reference, task schedule, I think it's this. Types, okay, this is it. This is what I intended, okay? For the task scheduling. Long running work request, one-time request, periodic work request, okay? This is it. This is an example, okay? Begin unique work. I want to Work Manager. Let me just. Okay, this is scheduling work that is dependent, work items that are dependent between them. Okay, it states, look, do this, then do this, then do this, and then do this. If the first one fails, it will not execute them. This schedules a chain of dependent work, okay, to be executed. And it ends with saving the image to the gallery. Cool. Work Manager, okay. So I will link you guys this in our outline, class outline. Finally, for today, I have a last message. I have a last message for today. Have you ever been looking at application and the screen fades? Ever seen that? You know what I mean? You're looking at something and suddenly the screen fades away, becomes darker, and finally it turns off. And you were looking at something, reading a web page, right? For example, you are reading something. When you are on YouTube, that doesn't happen. Why is that? Well, because the browser does not hold a wake clock. For you guys to control the screen being awake or not during something, you can use wake clocks, processor wake clocks, screen wake clocks, meaning that these locks are the means to ensure that the screen does not fade away while using some part of our application. It's a game, right? We are in game mode. Imagine you are playing a game of Clash Royale, which is rage-inducing enough, right? It fades away while you are in the heat of the game, what happens? Well, the phone will fly away, right? It will fly away, far, far away. It's not cool. And then, whose fault is it? Well, the developers, because you know what? Devs are always to blame. Okay? Always. Because it's us that do the stuff, right? So it's our blame for the good and for the bad. It's like that. Simple as that. Okay? So these are wake clocks. If you guys want to have control over screen being dimmed or turned off or not, then you must look into wake clocks. Okay? Wake clocks. I will write it. I will link you guys here. Android. And there's a lot more, okay? Android is one of the most complex execution systems that I know of. Okay? It's complicated as hell. Okay? I am just trying to give you guys the simplistic view until today. Today I'm revealing the world that this is. There's a lot more, okay? So if you guys are wondering whether you can go to whenever if you listen to people say, look, what, front-end developer, that's easy. They never did it, that's for sure. They never did front-end developer, and for sure they never did Android development. Okay, it's not easy enough, really. Now, about multi-platform, you guys understand the difficulties of multi-platform with this? I'm just, yeah, this will be different from system to system. It will be different, for sure. Meaning that although we can make sure that we are having most of our functionalities supporting whatever platform it is, these issues are important and are distinct from one system to another. Okay, in the browser as a target, many of this stuff is not an issue. In iOS, for instance, as a target, some of these things are issues, but they have different approaches. So you see, multi-platform itself, while we stick to what we have been seeing thus far, it's mostly the same thing. But once we go and think of this, well, stuff changes, okay? So this is another element to consider. Android wake clocks. Let me just, I will link you guys this, Android wake clocks. You were asking me about wake clocks, background work, use wake clocks, okay? I will link you guys to this too. Finally, task scheduling, foreground service, background, okay? Finally, let me just give you a last heads up. Wake clocks. Okay. No, well, let's keep it this as well. So wake clocks, importance of processes, background work, foreground services, task scheduling through Work Manager API, and wake clocks to make sure the screen doesn't dim away. Okay, cool. And the activity lifecycle. Yeah, I think that's it. Yeah, specific OS API implementations, exactly. So I'm going to end today's talk, okay, regarding focusing on this, okay? If you guys wish to, just imagine you start working on a code base, on product code base. Well, you will have these things there, okay? They will be there. Unless you are starting fresh, building anew. If you are building anew, you must be aware of this, okay? So you don't have false expectations regarding how your application will behave or not, okay? Keep this in mind. Once we are starting to build a product, many things that we are not concerned here in our playground, that will become a concern, for sure. Okay, so again, and I will end with it again, the answer to the question, are we ready to start to be Android engineers? Yes. You are prepared to start from day one to be productive. Will you be self-sufficient? No, not yet. But if you remember these things that I'm telling you guys, you at least you will be aware of this need and you will be capable of going after that by yourselves. Okay, it's better for us to understand a priori beforehand what will be the challenges. Other challenge is screen diversity. Okay, device diversity. Device diversity in the libraries, native libraries, device diversity in screen resolutions, densities and sizes, foldables and whatnot. That is a huge headache. Okay, I will never bring that up in this class, but you be sure to need to worry about that when you are in a product. Okay, it's a requirement. We need. Is it rocket science? No, not at all. We have variants. We have several variants to address that, but it's a hassle. Okay, it's not great. So whenever you hear Android development is easy, you may laugh and understand that the person who's saying it never built anything with Android, at least not for real. Okay, guys. So I will end with it. Okay. I don't want to deter you from being Android engineers. I've been one. Okay. I loved it. It's not that. It's just I don't want you guys to believe in fairies. Okay, this is not a fairy tale. I've been simplifying this approach from the beginning. Some of you guys just told me, well, this is simple. Thank you. Okay, I work hard to make sure that it seems simple, but it is not. Okay, if you guys follow my lead thus far, it will give you some sense of peace and tractability to understanding the solutions. But well, there are many things more than what I told you thus far. Okay, in the last week of the semester, until the 15th of December, all our classes will be practical. So you have yet time to pick this up and use it in your own project. I will help you guys in practical classes, and I will start to be more intrusive, meaning I will hassle you. I'm expecting you guys to be on practical classes. I will be asking questions one at a time, of course, and taking notes. It's now that starts the possibility of not having a discussion, an oral discussion. Okay, I will start to take notes regarding your solutions or your answers to my questions, and that will lead to a classification of your work or not. It may be deferred. For example, top performers, someone who wants to have 20, the maximum score, will have a discussion with me. Okay, at the end of the semester, after the exam. Okay, I have 20 potential 20 that I have promised to a student that was trying to get 20 in PC, concurrent programming, but I didn't think so. It was not Pedro Felix's fault, it was mine. Okay, I thought it was not there yet, but I told him you can have 20 if you show me in PDM that you really want it. So that those grades will require discussion. Okay, always from 18, 19, 20. I will not issue those grades without discussion. Okay, guys. So you keep that in mind. Once I will ask you guys, look, are you aiming at more than? You can tell me, and there's no point in continuing because we will have a discussion. The important grades, I only give those grades to the guys that really put in the work. Okay, you really need to put in the work to to have those grades. But there are other grades. It's okay. You guys know how you can use your own time. It's not judgment. It's, I understand you have a budget, a temporal budget, and you don't have the time to be spending as much in every class, okay? There's no judgment here. I'm just laying out the rules so you understand where are you aiming at, okay, guys? So this is it. This is it. Let me see what you're saying. Yeah, it's a great challenge, Sonder. Okay, thank you. It's a great challenge. It's great. I think I love it. So just don't buy it. Whenever people say Android and front-end development is easy, guys, don't buy it. Don't buy it. It's not. It's a different set of concerns. By the way, traditionally I love Rust. Rust, not the language, but the oxidation of the metal. Rust. Ferrugem. Nós dizemos, we say in Portuguese, I love ferrugem, because we are on the metal. I like to work on the metal. But somehow fate brought me to Android. Okay? Why? Well, it happened because it was required in our course here at ISEL, and well, I picked it up. I became Android engineer because I had this course. I became Android engineer in a company because I had this course. Because prior to that, I was working on the backend, on large scale. Okay, this is where I was working prior to becoming an Android engineer, and the type of concerns are different. Okay, when we are talking about the backend, we are talking about latency and throughput. Okay, those are the main concerns: latency and throughput. Throughput is about the number of requests we can handle per unit of time. Latency is how long does it take from the first stimulus until it's the received response, okay? And at the back end, we have to deal with this. On the front end, we have to deal with responsiveness, user experience, user perceived performance. Those are also demanding. They are different from the other ones, but they are also demanding, okay? So keep that in mind. That's it. I will end. Okay, guys. See you the 15th of December. It will be another lecture regarding offline operation and why does it matter. Okay. See you guys. Malta, fiquem bem. Thank you, guys. See you in a while. Let me just go to the next class. Bye bye. A segunda. Não são 2 feriados. Foi 2 feriados seguidos. Portanto, ou seja, durante 15 dias não há aulas à segunda-feira. E, portanto, se não há aulas à segunda-feira, sobra sexta ou quinta, dependendo. Portanto, e está tudo bem, não tem problema. Não. Aulas práticas, porque à segunda não há. Tá? Ok, até sexta.